We're getting ready to do a dry run, an air cut of drill hole pattern, which is every 2 inches, every 2 of those holes, so we could use that as a spoil board on this CNC machine. Here you can see the pattern on the controller software, which we're using Denby Candle. Just a drill cycle. And we're going to do that about 100 times. And that's how you make holes. This is the CAD here in Kanban. There's a bunch of holes in hole operations. They're organized. And you can kind of view the tool paths there. If I select on some, you could see some. I also simulated it to make sure that we're going to avoid any problems. And you can see that it's going here. Put on wireframe and you can see, oh, it's drilling a hole. Before drilling all the holes in the bed, I got to make sure that the machine is square. By measuring here, getting a measurement there of 45, and then over here, and that is 55 or plus 10 for the instructions. That'll do. Of course, you try and do that before you start doing the test cut with the machine moving around on its own, but I already did that. It's good. No time. Time to go. All right, we're ready to go. All right, here we go. Well, we removed the X drive because we were having problems with it, and moves pretty smoothly back and forth. We've got some tension from the wire on top, but that's to be expected. But the big thing I notice is that the zero backlash nut will not receive in its socket because it's offset. So we've got a misalignment here, and when that's all assembled together, it binds. How to fix that? Let's cut a hole. Nice. Let's cut a slot. These shims will constrain the zero backlash nut in the X direction, but will allow a little shifting in Y and Z to prevent binding. Cheap bits dull quickly. Job's not done until we clean up.